Arduino is amazing. It allows you to make many different things. Most homemade projects use some kind of Arduino board, from simple LED controllers to robotics and AI-powered contraptions. Basically, almost everything containing electronics. I would also like to make something myself and learn how to use Arduino. That's why I'm going to make Arduino laser turret. Or at least try to make it. Let's get it straight. I know nothing about Arduino, except that it is like a small computer. So you can treat this video series as a beginner intro into microcontrollers and electronic projects. I will try to include every step, my thought process and what tools, components and other things I used. Okay, first, why laser turret? Well, lasers are pretty cool, right? I've got an old laser distance meter lying around and figured why not use it. I can take out the laser module, put it on a rotating base and make it turn around. Simple enough. So let's make some plans. I think it is good idea to plan what I want to make. First things first, I know at the heart of this project there will be Arduino Uno board. I want to connect laser diode to it and be able to turn it on and off at first by a button push. So, the first phase of this project would be get Arduino board and basic components, learn how to use it, write a simple program to turn on and off LED diode, build and test my first circuit. The second phase would be all about electrical circuits, components and laser diodes. I want to understand how lasers work, see what do we need to make it work, and make a simple circuit connecting laser diode to Arduino. Third phase, make our laser move with motors. We need to get servo motors, or at least I think so, to move the laser around. Connect them to a board and maybe write a simple program to make them move. Fourth phase, add some firepower. The first laser diode would probably be more like an aiming module, so there are three options to make it into a turret. First, increase laser power. That would make it a true laser turret. But I think that it will have a limited use at home. Also, I don't want to burn my eyes and my home. Then there is a second option, a crossbow mechanism. Should be relatively simple and safe enough to use at home. And the last option, the one that I'm most inclined to do, pneumatic cannon. It will sneak some pneumatics to our project and allow shooting things without doing too much damage. Fifth phase, make some controls. First I thought about adding a camera and automatic targeting system, but I think it will be too much of a task for my first project. What I want to do is to add some kind of controller support. I have some old PS4 controllers lying around and connecting it via Bluetooth shouldn't be that hard. And final phase, make it look good. Tidy up cables, design and order custom board, optimize moving parts and basically make it ready to be placed and shoot. That is what I have in mind. There is a high chance that this plan will change as we move forward. Now let's actually start at phase 1 and see what we can do with Arduino. To start we need an actual Arduino board. There are many kinds of boards, but as a beginner I will go with a basic Uno board. The company that made Arduino is actually pretty chill. They let their designs be used by other companies to make clone boards. That's why we have a choice. Buy an original Arduino board, guaranteeing top quality, or try some cheaper clones with, well, unknown quality components. It is up to you, but if you can, support original creators. I choose a clone because I don't trust myself to not blow it up. Also, if you are going to buy Arduino, I suggest getting some pre-made kit. It should at least contain Arduino board, cables, breadboard and some basic components. I've got a cheaper one without fancy LCD screens. Now, download Arduino IDE from the official site, connect board to a PC, open the program, and now what? What I did is spend some time watching basic tutorials on YouTube, like Arduino Masterclass or Arduino course for everybody. Next, it is time to make some simple circuits using built-in sketches. I did a few of them to grasp the basics. Let's take a look at one and see what is even happening in there. This example is called Blink. Here in the nodes, which are this gray color, we can see that it turns an LED on for 1 second, then off for 1 second, and it repeats it. Also, there is an information that LED on the board can be controlled, and on the Uno board it is attached to a digital pin number 13. All of this part is just like a comment. It doesn't have any use in our code, so I will delete it. There are basically two parts to this code. One is the setup and the second is loop. First, the setup. Here the code is executed once, and then Arduino moves to the loop. Here in the loop function, our code is executed to the bottom, and then it goes back to the beginning, does it again, and so on, so on. Basically, it is always running. So, when you turn on the Arduino, it does setup and then starts to run the loop. You can see that in setup we have this line of code. It allows us to set our LED pin as an output, which means that the information is going out of the board to our components. This is the LED built-in, which also could be number 13. And with this our setup is done, so we can move to the loop. This command tells that we want to send digital signal through our LED pin, and we set it to the high, which means that it is basically on. Then it waits 1000 milliseconds, which is 1 second. Then it sends a signal through a LED pin, and this time it is low. You can say that high is like a 1 and low is like a 0. So on the high there is a signal and on low there is no signal. And then it waits another second. With this our loop ends and program goes back to the beginning. So it turns on the LED again, waits 1 second, turns off LED, waits 1 second, and so on, so on. Let's see how it looks on the board. This is how our circuit looks. You can see that the power goes from the pin 13, which is here, into the board, then through 220 ohm resistor, through a LED, then into a ground on the board, and from board into a ground on the Arduino. And when I plug it, it blinks. You can also see that the LED on the board is blinking. It is because the pin 13 is connected to the LED on the board. You could pull everything out and the LED on the board should blink. Just like this. Also, we could change the value of delay to half a second. Upload it. And then our LED starts to blink faster. Set it to lower value, 1/10 of a second. And it blinks even faster. Now, with basic understanding of breadboard circuits and programming, we could start thinking about what to do with an actual laser. For a few years I had old broken laser distance meter in my drawer, waiting for a new life. I remember that laser module worked well, but it didn't measure distance. So I tried to put batteries in and see if it works. It didn't work. I thought the diode may still work. Maybe it just doesn't receive any power. So I desoldered diode from the board. Now, as the name suggests, it is a diode, so I should be able to check it using multimeter. In one direction we should see high resistance and in the other direction some other value. Well, I think it doesn't work. That is unfortunate, but I don't really need it right now to build a simple circuit. Instead I can use LED diode in its place. Now it is the time to make first iteration of our project. Simple circuit with a one button that will turn on and off the LED diode. This is how the circuit looks like, and this is how it works. Pushing the button lights up the LED. So we have red wire is the power to the board, black wire is the ground, then from the pin number 3 power goes through a resistor to a LED and back to a ground. The pin 2 is an input and it tells us when the button is pushed on. And the button is wired like this. Power from the breadboard through a button, there is a signal going through a board, and it is connected to a ground through a 10k ohm resistor. And when you push a button, the LED turns on and off. You can even hold the button down and it doesn't mess with the LED. And there is our program. We have, of course, first the setup. There are 2 pins. Number 3 is a LED pin, number 2 is button pin, and those are additional variables that we are going to use later to monitor how the button changes. Here is the setup function. Here we start communication with board, and here we set up how our pins work. I don't need this. So pin number 3 is set as output. Button pin, which is number 2, is set as input. And then we go into loop. It starts with reading the button state, and then it compares our current button state with the last button state, and if it is different, it goes here. It checks again if the button is pressed and it's different than the last state. It adds 1 to a counter, which was set here, and this part is for checking what number is counter. Then it goes here and overrides the button state, waits a bit for stability, and then this is the part where it executes what the button does. If the counter is equal to 2, it should be if this part of the code was executed, then it lights the LED up, and if the counter is different than 2, so 1 or 3, it doesn't lit up the LED or just turns it off, and then it resets the counter to the 1. So it goes back and forth, and this part is probably the most important part. This allows us to check the button state, it compares it to the previous button state, so it allows us to detect when we press the button or when we let it off. And then this is checking if the button was pressed or let off, and if it was pressed, it updates the counter, updates the button, waits a bit, and then checks what to do with our LED. I've gotta say, it feels great to make it from scratch and learn something new. Now, since we can make basic circuits and program in Arduino language, we could go to a next phase. As I said, I wanted to test a LED diode, but it turned out to be a bust. That is not a problem. Now I just need to buy some laser diodes, and in the next video we could get right to it. If you have any tips or just enjoyed this video, leave a comment. Also subscribe and like this video, I would really appreciate it. If you want to make this project with me, I put the most important stuff to get in description, as Amazon affiliate links. See you in the next one.